Today in the workshop, we'll be discussing power sources for your electronics projects. We'll be working with voltage regulators, buck converters, boost converters, and buck-boost converters to supply a steady source of electricity for your electronic designs. We're all charged up and ready to go, so welcome to the workshop. Hello and welcome to the workshop. Now, the subject of today's video may not seem as thrilling as something like building a flying nuclear-powered robot or something like that, but it is actually an essential subject, and we're going to be talking about providing electricity for your projects. Now, if you're working on your workbench, this probably isn't an issue. You may have a workbench power supply already, but even if you don't, if you're using something like an Arduino Uno, you can simply plug it into your computer and use the USB power from the computer to power the Arduino. In addition, the Arduino also has a built-in 3.3 volt regulator to give you 3.3 volts for those peripherals that need it. However, if you're planning on going beyond that, you're going to need some source of powering your project. Now, if your project is going to take the entire Uno and mount it in a box, then you can continue to use a USB power supply, or maybe plug a 9-volt adapter into the jack on the Uno and use its built-in 5-volt voltage regulator. However, if you're doing something like taking the chip out of the Arduino Uno and using it in your project on its own, or basically building something that doesn't even use a microcontroller but requires 5 volts or 3.3 volts, then you're going to need a source of voltage, and that's what we're going to talk about today. I'm going to show you a number of methods, either line powered or battery powered, that you can use to supply the voltage or voltages that your project requires. So I've got a number of different devices here to look at today. Before I do though, I want to show you the little test setup that we're going to use in order to demonstrate all of these devices. Okay, I want to give you a quick look at the test setup that we're going to be using to test all the voltage regulators and converters that we're going to be discussing today. I've got something sitting here on a solderless breadboard for you. Now, I've got two Arduino Pro Minis over here, and as you can see from the flashing light, they are simply running the blink sketch right now. But this is sort of like the old Sesame Street routine. One of these things is not like the other. This is a 5-volt, 16 megahertz Arduino Pro Mini, whereas this is a 3.3 volt, 8 megahertz Arduino Pro Mini. So these two devices have different voltage requirements, and we're going to use a number of different regulators and converters to power them up today, and I'm going to show you how to do that. Now, before we start discussing voltage requirements, regulators, and converters, I want to quickly show you how I'm powering up these two Arduino Pro Minis. As you can see, they're both running at the same time, so I'm obviously giving them a source of both 5 volts and 3.3 volts. And what I'm using is this little device here. This is a breadboard power supply, and you can buy these things in sheets. I've got a sheet of them over here, and you can just snap these things off when you need them. These devices are really cool though. I've got one over here mounted on this style of solderless breadboard, and they snap into the breadboard rails, and they have these jumpers over here to allow you to apply either 5 volts or 3.3 volts to the two different breadboard power rails. They also have a USB power output. There's a 2.1 millimeter jack on this that'll let you feed power in from an AC adapter or a 9-volt battery. There's a power switch on here and even a power LED. Now, while these devices are really meant for solderless breadboards and for experimenting, they also make pretty good power supplies if you're going to line power a device that needs both 5 volts and 3.3 volts at a low current requirement. So don't overlook something like this as a simple method of powering up your projects. But having said that, let's move on and look at some other converters and regulators that we can use inside our projects. Now, when you're powering up electronic projects, you're going to find there's a number of common voltage requirements. Now, we've already mentioned 5 volts and 3.3 volts that I'm using to power these two Arduino Pro Minis. Those are logic level voltages, and they're the two most common logic level voltages. 5-volt logic has been around forever. I was using that back in the 1970s. And 3.3-volt logic has been around for quite some time as well. Now, both 5-volt and 3.3-volt logic have very stringent voltage regulation requirements. For example, with 5 volts, you cannot go below 4.75 volts or above 5.25 volts. Going too high can actually damage the components, and going too low can cause erratic operation. Things just aren't going to work correctly. 3.3-volt logic has the same stringent requirements. In addition to 5 volts and 3.3 volts, there are some other voltages that you're going to run into. 6 volts and 12 volts are very commonly used with motors, with servo motors, with stepper motors, with DC motors. You may also have an H-bridge in your project, and that has a voltage drop on it. So in order to provide 6 volts for a motor, you'll need 7.4 volts. Now, we're going to take a look at regulators and converters that can supply all of these voltages, whether it be logic level voltages, higher voltages, or lower voltages. Keep in mind your project may need more than one voltage, and if you're using a battery, that can create a bit of a problem, because what do? Use multiple batteries or use one battery to supply all of the voltages? Well, I'm going to show you how you can solve all of those, but before we take a look at our converters and regulators, let's take a look at some of the basics of powering up your projects. So let's take a brief look at power supplies. Now, a power supply provides a regulated or unregulated DC voltage to operate your electronic components. The supply needs to maintain this voltage level at up to its maximum rated current. Now, power supplies can have a DC input or an AC input. Now here's a diagram of how an AC power supply would work. Notice that this is a linear power supply, and switching supplies like the ones you have in your desktop computer work on a slightly different principle. Essentially, we have an AC voltage source. This is usually the voltage source in your wall outlet, and will range from 120 to 240 volts depending on where in the world you are. That voltage needs to be brought down to a reasonable level, so we use a form of level conversion. This is generally just a transformer. After that, the AC voltage is converted to DC. This is usually done with a rectifier or bridge rectifier circuit. Finally, that DC voltage passes through a voltage regulator in order to produce the correct output voltage. Now, when using a battery supplies, things are a lot simpler. The first example we'll look at uses a linear voltage regulator. It takes a battery of a higher voltage than the output voltage and passes it through a linear regulator. Another method of doing this is with a device called a buck converter. Again, a battery of a higher voltage is passed into the buck converter, which will produce a regulated voltage at a lower level. There are situations where we need an output voltage that is higher than our battery voltage. In this case, we would use a boost converter. A battery of a lower voltage is passed into a boost converter, which produces an output voltage at a higher level. Finally, we look at the buck boost converter. This is a converter that can accept an input voltage either higher or lower than its output voltage, making it ideal for battery-powered devices. So before we get started, I wanted to show you a couple of the devices that I keep around the workshop in order to satisfy the power requirements in some of my projects. Now, up here, I've got a box of linear voltage regulators. These are 3-pin voltage regulators, and these are kind of a staple in the industry. And I've got several different types over here, a couple of which we are going to be looking at in a few moments. This is another 3-pin voltage regulator over here. It's a very tiny 3.3 volt linear regulator, and we'll take a look at that as well. Now, this is an entire power supply unit. It actually takes in either anywhere from 110 to 220 volts and outputs 5 volts. This is indeed what you'll probably find inside a lot of the power bricks. Now, I don't necessarily recommend that you use these unless you know how to work with high voltages, and so I'm just pointing this out because I do use these in some permanent projects. When you're using this, you want to put it inside an insulated enclosure and observe proper wiring precautions and proper fusing precautions. Now, these two little devices over here are actually USB breakouts. This is a standard USB and it's a micro USB, and this is a great way to get 5 volts off of a USB power supply. And so you can just use one of these in your circuits, and it's a lot easier than trying to solder one of these connectors onto a circuit board, because you're going to find that the pins don't exactly conform to most breadboards, but these make it very easy to get 5 volts off of a USB power supply. Now, this is a buck converter. It's not one of the ones we're going to look at today, but it's more of a heavy-duty buck converter. It's got terminals for an input and an output, and it's got a potentiometer over here, a 10-turn pot that allows you to set the voltage very precisely. It even has its own 3-digit display so that you can actually read the voltage directly on the device. It's a handy thing. This, of course, is the breadboard power supply that we looked at a bit earlier. Now, here are some of the devices we are going to look at today. There's a couple of converters over here, a buck converter, a boost converter with a USB output, another little boost converter, a couple of linear regulators that are mounted onto breakout boards to make them very easy to use, and this device over here, which I'll show you at the very end, is actually my very favorite. This is a buck boost converter that can both take higher or lower input voltages and provide a steady output voltage. It's a perfect thing for battery powered projects. So just a few of the devices that we will be looking at today, I wanted to show you that I keep around my workshop. The first linear regulator we'll look at are the 7800 series of linear voltage regulators. The 7800 series is a popular 3-pin voltage regulator family that has been around for several decades. The XX in the part number indicates the output voltage, so a 7805 is a 5-volt regulator, a 7812 is a 12-volt regulator, etc., etc. There's also a 7900 series of negative voltage regulators that have a similar part numbering scheme. The 7800 series is available in several different packages. The most common package is the TO220 or power transistor package. When packaged in the power transistor package, the 7800 has an output capability of up to 1.5 amperes if it is heat sinked. The pinouts on the 7800 are very simple. Pin number 1 is the input. Pin number 2 is the reference pin, which is generally tied to ground, and pin number 3 is the output. The 7800s are quite easy to use. They require only 2 external components, small electrolytic capacitors. These capacitors are of no specific value. Generally, I use 2.2 microfarads for the input capacitor and about 100 microfarads for the output capacitor. So I've got a 7805 regulator powering my 5 volts Arduino Pro Mini, and as you can see, it's doing it quite well. My power supply is currently set to 9 volts, which is what I'm feeding into the regulator. This is measuring the current that's being drawn from the supply. You'll notice it's fluctuating in time with the flashing LED. This is measuring the output voltage, which as you can see is very close to 5 volts. The regulator is hooked up identically to what I just showed you in the diagram. So pin 1 is the input, pin 3 the output, pin 2 is grounded, and I've got a 2.2 microfarad capacitor across the input and a 100 microfarad capacitor across the output. And that's basically it, a standard 3-pin voltage regulator powering up an Arduino Pro Mini. And although these voltage regulators, like I said, have been around for decades, They're still excellent devices to use in your power supplies, especially line-powered supplies where you're not too concerned about the efficiency of the regulator, because there are more efficient regulators and converters that I will be showing you in a moment. So let's move on to our next voltage regulator. The next linear regulator we'll look at is the LM317. The LM317 is a 3-pin variable positive voltage regulator. Its output voltage can be set from 1.25 to 37 volts DC. You set the output voltage by using two external resistors. The LM317 can supply current of up to 1.5 amperes. Now here's the pinout of an LM317. Pin 1 is the adjust pin. Pin 2 is the output. And pin 3 is the voltage input. Now here's the circuit for hooking up an LM317. Notice this is a little bit more complex than the 7800 series regulators we just looked at. The two capacitors again are not critical. I usually use a 2.2 microfarad capacitor on the input and a 100 microfarad capacitor on the output, but again any values will suffice. The two resistors R1 and R2 determine the output voltage. The output voltage is determined using the following formula. When calculating output voltage, you generally use a value of between 240 and 270 ohms for R1. However, any value in that ballpark will suffice. Keep in mind that making R2 a variable resistor or a potentiometer would allow you to create a variable output voltage regulator. Now here's a demonstration of the LM317 linear voltage regulator, the one with the variable output. I've got it set to give about 5 volts out, and it's powering the Arduino Pro Mini, and as you can see from my power supply, I'm giving it 9 volts in. Now I've got a number of components on this. This device needs more components than any of the other regulators or converters that we'll be looking at today. I've got a 2.2 microfarad electrolytic capacitor filtering the input, and I've got a 100 microfarad electrolytic capacitor across the output. Now the value of those two capacitors is not critical. You can use anything in that ballpark and it should work fine. I've also got two resistors that determine the output voltage. Remember, this is a variable output linear voltage regulator, and it's these two resistors that determine what the voltage will be. So I've used a 220 ohm resistor from the adjust pin to the output pin, and an 820 ohm resistor from the adjust pin to the ground, and I calculated this would give me just slightly less than 5 volts, and certainly it actually does. So this is a great regulator to use, especially when you're looking for a voltage that is a bit of an oddball. Let's say you needed something like 9 volts or 7.4 volts or something like that. This would be a good device to use. And again, it's in a TO220 package, so you could put a heat sink on it and get a reasonable amount of current out of the device. So now that we've looked at this linear regulator, let's move on and look at something else. Now let's look at another linear voltage regulator, this time a module. The PSM165 linear module is a small breakout board with a 3.3 volt linear regulator. It can accept an input from 4.5 to 12 volts. The PSM165 provides an output of up to 800 milliamps. Interestingly, this is the same regulator that is used on the Arduino Uno to supply 3.3 volts. The PSM165 has several connections, allowing a lot of versatility in how you hook it up. Starting on one side, we have the ground, an input, the ground, and an output. On the other side, the ground, an output, the ground, and the input. You can use any of the output, input, and ground connections to wire the PSM165 into your circuit. So here's the PSM165 module. It's powering the 3.3 volt Arduino Pro Mini. As you can see from my power supply, I'm feeding it 5 volts, and it's consuming a very, very low amount of current, and again it fluctuates in time with the LED flashing. I've got a good healthy output voltage, almost exactly 3.3 volts, and I've used 2 of the pins on this side for the input to the module, and 2 of the pins on the other side for the output. And as you saw in the diagram, there are several different combinations of pins you can use for input and output. And the module itself also has a tiny power LED on it. So a very simple module to use to supply 3.3 volts for your projects. Our next linear regulator is another module. The AMS 1117-5 is a small breakout board with a 3-pin linear regulator. This regulator has a much lower voltage drop than the 7800 series, making it practical for battery-powered operations. The AMS 1117-5 has an output of up to 1 ampere. Using the AMS 1117-5 is very simple. A connector on one side has the input and the ground, and the connector on the other side has an output and the ground. The module has all the decoupling capacitors necessary, and even a small little LED for power indication. So here's my AMS 117-5 module. It's powering my 5-volt Arduino Pro Mini. Now, as you can see from my power supply, I'm only giving it 6.5 volts because this is a low voltage drop regulator, so I can actually go down as low as 6 volts and still get 5 volts out. It's also consuming a little less current, and when you consider voltage multiplied by current as power, I'm taking less power than I would with a 7800 series regulator, so this module could be used with a battery-powered design. The output over here is very good. It's almost exactly 5 volts. And the hookup for this could not be any simpler. I've got the 2 wires coming from my power supply going to the input, and then the 2 wires coming from the module output are feeding this 5-volt Arduino Pro Mini. So a very simple regulator to use in your designs. It's useful as well for battery-powered designs too. The last linear regulator we'll look at today is a tiny device with a huge part number. The L4931CZ33, or CZ33 for my American friends, is a 3.3 volt linear regulator. This device has an extremely low voltage drop of 0.4 volts, making it ideal for battery-powered equipment. This series is also available in a 5-volt regulator. The maximum current of this device is 250 milliamperes. The pinouts of the L4931CZ33 are as follows. The first pin is the output pin, the center pin is the ground, and the third pin is the input pin. In practice, this device is hooked up exactly the same as the 7800 series of voltage regulators, with only 2 capacitors required. Notice that the input capacitor does not need to be an electrolytic capacitor. It can just be a small ceramic device. And so here we have the little voltage regulator with the big part number, the L4931CZ33 regulator. Now I'm powering up my 3.3 volt Arduino Pro Mini with it, and I'm feeding it 6.5 volts. As you can see, it's consuming very little current, and I've got a pretty good output, almost exactly 3.3 volts. Now I've wired this up as per the diagram. I'm using a tiny ceramic capacitor. I'm using a 100 nanofarad capacitor on the input and a 2.2 microfarad electrolytic capacitor on the output. Otherwise, the wiring is pretty simple for this device, and it works quite well. This would actually be a very good device to use if you have a 5-volt logic circuit and you just have a couple of 3.3 volt devices that you need to power up. A small regulator like this is very inexpensive and is quite efficient. So now that we've seen a few linear regulators, let's take a look at another form of regulating voltage, and this is the buck converter. Now, like a linear regulator, a buck converter takes a higher input voltage and provides a steady output voltage at a lower level. However, they work on an entirely different principle than linear regulators. They basically look at the expanding and collapsing magnetic field on a coil, and they use that energy to provide an output. Now, buck converters can be very efficient. Some of them have efficiencies exceeding 95%, and so they're ideal for battery-powered devices. They can also supply a decent amount of current in a very small package, which is another advantage of using them. So let's take a look at a couple of buck converters now. The buck converter we're going to look at today is the Mini 360. This is a very compact buck converter that has a 95% efficiency. The Mini 360 can accept an input from 4.75 to 23 volts DC. It has a variable output that you can set from 1 to 17 volts. The Mini 360 can supply up to 1.8 amperes continuous and peaks of up to 3 amps. Using the Mini 360 couldn't be simpler. On one side you have two connections, the input minus and the input positive, and on the other side two other connections, the output minus and the output positive. So here's the Mini 360 buck converter powering up the 5-volt Arduino Pro Mini. Now, as you can see from the power supply, I'm feeding it 6.5 volts, and I've got the output set to pretty well exactly 5 volts right now, and it's working quite nicely. Now, the Mini 360 has a small potentiometer on it that you turn in order to set the output voltage, and you should set this before you connect your load up, because keep in mind this is capable of producing a wide range of voltages, and you could exceed the amount of voltage you want for your load, in this case the 5 volts or the Pro Mini. Now, it's a single turn potentiometer, so it's a bit touchy as to where to get the voltage set, but once you get it set, it's pretty stable, as you can see from the meter over here. If you're in a commercial environment, you might even consider some sort of a sealant on the pot after you've got it set to the correct position so that it won't move. Otherwise, the hookup to the Mini 360 really couldn't be simpler. I've got the two leads going to the input over here, and the two leads for the output going over here. And so that is the Mini 360 buck converter. Now, buck converters and linear regulators are really great when your input voltage or battery voltage is higher than the desired output voltage. But what do you do when you have the opposite situation? Let's suppose you have two AAA cells and you'd like to power a 5-volt project, but of course you've only got 3 volts to do it with. Well, for something like that, you can use a boost converter. Now, as the name would imply, a boost converter provides an output voltage that is higher than its input voltage. And they actually work along the same principles that the buck converter works on. In fact, it's just a different way of wiring a coil, a transistor, and a capacitor that makes a converter a boost converter as opposed to a buck converter. So I've got a couple of little boost converters over here to show you. So let's take a look at them right now. The first boost converter we'll look at today is a rather unique device. The PSM205 is a boost converter with an integrated USB jack on the output. It accepts an input voltage as low as 0.9 volts up to 5 volts DC. It will output 5 volts at up to 600 milliamperes. The PSM205 operates at up to 96% efficiency. Using the PSM205 couldn't be easier. Two connections on the input for the positive and negative voltage, and you simply plug your device into the USB jack to receive 5 volts of power. So here's my PSM205 powering up my 5-volt Arduino Pro Mini. Now notice from the power supply I'm only feeding 2.5 volts into the device, and yet I'm getting a very healthy output. It's actually a bit above 5 volts right now. Now the hookup, of course, is extremely simple. I've got my input going into the 2 pins on the PSM205, and the USB output is being used to power up the Arduino Pro Mini. So if you need to power up a USB powered device, and let's say you want to use something like a coin cell or a couple of AAA batteries, this would be an ideal module for that situation. The other boost converter that we'll be looking at today is the MT3608. This is a compact boost converter that has an adjustable output. It accepts an input from 2 to 24 volts DC. It provides an output of up to 28 volts at 2 amperes. The MT3608 boasts an efficiency of up to 97%. Using the MT3608 couldn't be simpler. On one side we have an input where the positive and the negative are connected, and the other side is the output with the positive and the negative. A 10-turn precision potentiometer on the board is used to set the output voltage. So here's my MT3608 powering up a 5-volt Arduino Pro Mini. Now as you can see from my supply, I'm giving it 3.3 volts, and I'm getting a 5-volt output for the Pro Mini. Now of course this is an adjustable regulator. There is a 10-turn trim pot on here that you use to set the output voltage. And one very important thing to do is to set that output voltage before you connect it to its load. For example, when I initially applied power to this and gave it 3.3 volts, I got a whopping 15 volts out. Now had I applied 15 volts to my Pro Mini, I would have certainly destroyed it. So I used the trim pot here, set it down to 5 volts, and then attached my load, and everything works fine. So this is a very versatile boost converter. It can boost voltages quite high from a very low voltage. It's ideal for powering things like motors, etc., when you have a battery that doesn't quite have sufficient voltage for your motor. The hookup, of course, is extremely simple. 2 terminals on the input and 2 terminals on the output. So we've looked at linear voltage regulators and buck converters, which can take a higher input voltage and provide a lower regulated output voltage. We've also looked at boost converters now, and as we've seen, they can take a lower input voltage and provide a higher regulated output voltage. But there's another situation that we can run across with battery-powered devices that don't really fit into either scenario. And so I want to show you one more component, a component that I think is absolutely fabulous, to tell you the truth. And this is something called a buck boost converter. So it's basically a buck converter and a boost converter in the same package. Now the advantage of something like this can be seen when you're using a battery-powered device. Let's say, for example, that you need 5 volts and you've got yourself a 7.2 volt LiPo battery. Well, a linear voltage regulator with a low voltage drop or a buck converter would be an ideal thing for this, and it will work fine until the battery voltage starts to drop. Remember, as you start using a battery, its output voltage can start getting reduced. When that voltage drops below a certain level, your buck converter or linear regulator will not work, and at that point you'd be saying, hey, I wish I had a boost converter. Well, a buck boost converter can do both. It can take an input voltage that is either higher or lower than the output voltage and provide a steady regulated output voltage, and it can do that as the power supply fluctuates. So it's perfect for this scenario that I just described. By using a buck boost converter, I can supply my 5 volts even when the battery voltage drops below 5 volts. And so I've got a really neat one of these to show you. As I said, it's one of my very favorite components. So let's go take a look at that right now. The buck boost converter that we'll be looking at today is the S9V11F5. This is a buck boost converter that has a 5 volt DC output. It can accept any input voltage from 2 to 16 volts. However, you need at least 3 volts to start the converter up. The voltage can then start dropping toward 2 volts. The output of the S9V11F5 can be up to 1.5 amperes with a 2 ampere peak. This is an extremely tiny device that has only 3 pins. Using the S9V11F5 is extremely simple. The 3 pins are as follows: the input pin, the ground pin, and the output pin. You can use this in place of a normal 3-pin voltage regulator, although you don't actually require capacitors on the input and output, as they're already integrated onto the circuit board. One thing to note about this converter though, it can get very hot, so make sure you consider that when you're laying out your circuit board. So here I have my S9V11F5 buck boost converter, and it is powering my 5-volt Arduino Pro Mini. And as you can see from my power supply, I'm feeding it 5 volts and I'm getting about 5 volts out. Now of course there's nothing remarkable about that, a piece of wire could do that. But let's see what happens when I change the input voltage. I've got some other voltages stored over here. So here's 3.3 volts. And as you can see, at 3.3 volts, I'm still getting the same output, and I'm still powering the Pro Mini. We'll go to the opposite end of the scale, and here's 8.5 volts. And once again, I'm getting the same output. So it doesn't matter what the input voltage fluctuates to, the output is still 5 volts. And of course, this would be superb for a battery-powered device whose voltage is higher than 5 volts, but eventually falls below 5 volts. So once again, this is my favorite little device for powering battery-powered 5-volt logic. So we've now come to the end of today's video, and we've covered quite a few different things. We've gone over linear regulators, buck converters, boost converters, and even a buck boost converter. And among all of those, I'm sure you'll be able to find something that you can use to power up your next electronic project. Now, if you want more details on any of the devices that we have looked at today, please visit the DronebotWorkshop.com website. You will find an article that goes along with this video that describes the devices we've looked at in detail, and will also give you links to other articles and spec sheets so that you can begin using these devices right away. Now, while you're on the website, if you haven't already, please subscribe to the newsletter. The newsletter is not a sales thing. It's my way of keeping in touch with you, to let you know what I'm working on in the workshop, and to also give you the occasional survey so I can find out what sort of videos and articles you would like me to create for you. And finally, if you haven't already, please subscribe to the YouTube channel. I would really appreciate that. You will find a link below the video for that, and also in the corner of the video there's a little robot holding a subscribe sign. Just click on that little guy and you can be subscribed to the channel too, and that way you will find out about all of the new videos that I'm creating for you. So until we meet again, please take care of yourselves, and I hope to see you soon again here in the workshop. Goodbye for now.